This LOS is determine the probability that a normally distributed random variable lies inside a given interval. A quick little review on some of the properties of a normal distribution. So remember, about 68% of all observations fall within the interval of the mean plus or minus 1 standard deviation. And approximately 95% of all observations fall in the interval of the mean plus or minus 2 standard deviations, and approximately 99% of all observations fall in the interval of the mean plus or minus 3 standard deviations. But in general, we do not observe the population mean or the population standard deviation of a distribution, so we need to estimate them. We estimate the population mean, mu, using the sample mean, which is x bar, and estimate the population standard deviation using the sample standard deviation. There are two steps in standardizing a random variable x. Subtract the mean of x from x, then divide that result by the standard deviation of x. If we have a list of observations on a normal random variable x, we subtract the mean from each observation to get a list of the deviations from the mean, then divide each deviation by the standard deviation. The result is the standard normal random variable z. Z is the conventional symbol for a standard normal random variable. So we have, how do we calculate the z? It's the x minus the mu divided by the standard deviation. We can then answer all probability questions about x using standardized values and probability tables for z. So the standard normal random variable is z. To find the probability that a standard normal variable is less than or equal to 0.24, for example, locate the row. So we're going to look at their z tables. We're going to locate the row with 0.2 and then look at the 0.04 column, and we're going to get 0.5948. So what that means is that when we have the standard the normal distribution, then 59.48% of the observations are going to lie below that, to the left. All the area under the normal curve to the left of x is the number that we're getting from the z table. Okay, so you can see we find the entry 0.5948. Therefore, the probability that z is less than or equal 0.24 is 59.48%. Okay, let's work our way through a little example now. Remember that the LOS is determine the probability that a normally distributed random variable lies inside a given interval. So that's part 2 to this question. So we have our normal curve, okay? And we're assuming that the portfolio mean is 12%. Okay, that would be an x bar, that would be a sample mean. And the standard deviation of the return is 22%. Okay, standard deviation is going to be 22%. So you want to calculate the following probabilities. The first one would be, what is the probability that the return will exceed 20%? So we're going to be looking to the right-hand side of 20%. And then the second one is we want to know the probability is what was the probability that the return will be between 12 and 20%. So what is the probability here? In other words, what is the probability above or equal 12% or less than equal 20%? Okay, and that's the key point to this LOS. Okay, let's work through this little example. So you're going to assume that the portfolio mean is 12%. And be careful, that's going to be our Greek symbol for mu. And the standard deviation of the return estimate is 22%. So that's our standard deviation, okay? So you want to calculate the following probabilities, assuming that a normal distribution describes the returns. So the first thing that we're going to calculate is what is the probability that the returns will exceed 20%. So remember, our mu is 12% and our standard deviation is 22%. We want to calculate what's the probability that our return could be above 20%. So the first thing that we're going to do is we're going to calculate the z. So how do we do that? X equals 20%. The z equals, remember there's the formula, x minus mu. So 20% minus 12% divided by the standard deviation is 22%. So we're going to get 0.363636. So we want to find the probability that z is above 0.363636, okay? So remember, we're looking to the right. We want to know that the return is above 20%. So we're going to go to the z table, and we're going to round it to 0.36. We're going to look at the number, and to the right is going to be 1 minus, because remember when we look at the z table, that's giving us the probability to the left of that number, okay? So when we look at the z table, we're going to find that for n equals 0.36, we're going to get 0.6406. So 1 minus 0.6406 is going to give us 0.3594. So we're going to have about a 36% chance that our portfolio return will exceed 20% if your normality assumption is accurate. Let's just go through that example again slowly with the table on the slide this time. So again, assuming the portfolio mean return is 12% and the standard deviation is 22%, what is the probability that the return is going to be greater than 20%? So that's to the right. So the first thing that we do is we need to calculate the z. And so for x equals 20%, 20 minus 12% divided by 22% gave us 0.3636. So we rounded that. So again, that's why I just wanted this one with the table on the same slide. We're going to go to 0.3 on the row and 0.06 on the column, and we're going to get the number 0.6406. Now that would give us the probability that the return is less than 20%, okay? But we're asking for the return, the probability that the return is greater than. So remember, what we need to do is we need to do 1 minus that, and we're going to get a 36% probability that the return is greater than 20%. So just remember, note that for the probability to the right of x, we have to have 1 minus the nx. And that was the key point. So that takes you through the that first part of it with the table. Shouldn't be too much difficulty with that now. Now we're getting into the second part of the question. So again, the portfolio mean return is 12%, okay? So here we have our normal, assuming a normal distribution, and our mu equals 12%, okay? And the standard deviation of the return is 22%. So we calculated the first probability, that the probability of return above 20% was going to be 36% approximately, okay? And now, though, we want to calculate what is the probability of the return between 12% and 20%, because remember, this LOS is determine the probability that a normally distributed random variable lies inside a given interval. So inside the given interval, the interval's from 12% to 20%. So in other words, what is the probability that the return is going to be greater or equal than 12% or less than equal to 20%, okay? So we did the first part, okay? So what we're looking at here is that we're going to look at the n, the z according to 20%, minus the z corresponding to 12%. So for the first term, we did it. We did it in the first part of the question. We knew that the returns under 20% was going to be 0.6406%. The probability that the return was under 20% was 64%, because we know that the return above 20% was going to be the 36. Now, this is a bit of a trick question, and it becomes pretty clear, because we're asking for the probability between 12% to that 20%. Now, remember, the portfolio mean was 12%. So this is a bit of a trick question in a way. So we know 50% of the observations to the left of 12%, and 50% of the observations are going to be greater than 12% because we're assuming that normal distribution and that it's symmetrical. So now we can solve. We know that to the left of 20% is 60.046, and we know to the right of 12% is 50%. So it's easy. It's just going to be 0.6406 minus 0.5, and we know that there's about a 14% probability that the return is going to be between 12% and 20%, because from 12% to the right is going to be 50% of all returns, and from 20% to the left is going to be 64% of all returns. So 64 minus the 50, 14%. And that's the last slide for this LOS. Thank you.